To create a new data frame and fill it with our new PCA component data, I wrote this code. The first thing I'm doing is creating a totally new data frame to hold all my new transform data. And then I'm going to iterate through each data point in our PCA component data. And I'm getting our component values from what I saw before, getting the label, projection, and our float32 tensor values. Then I'm passing this list of components and appending it to our county's transform data frame. Now this is going to be all 33 of our PCA components for each of our data points. Next, I know I still want to index by state county, just as in our county scaled data frame, so I'm setting our index accordingly. Then I know I only want to keep the top n components. I don't want all 33 of these features. I want, say, the top 7. And I know they're ordered from least to most important. So similar to how we've handled this before, I'm getting a start index, and then I'm getting a selection of data from that start index onwards. Finally, I'll return that truncated data frame in reverse order, so I'll have my top component as the first column in this transform data frame. Now I can run this code and select top n components to create our new data, and I'll create our 7 top components because I know that captures 80% of our data variance. So I'm calling my create transform data frame function. I'm passing in my PCA component data for each of my data points and the original county scaled data frame. And finally, I'm passing in 7 top components. And this is the resultant data frame. So I'm still indexing by state county, and I have the values for components 1 through component 7. And I'll actually want to take one more step. Instead of having numerical values for each of these columns, I'm going to create a list of columns that's more descriptive. So component 1, 2, 3, up to 7. And you can change these names to whatever you want. So now I have a list of counties and their component values. Now that I have my transform data, I no longer need my PCA model endpoint, and I can delete it with a call to our SageMaker session.delete endpoint, and passing in the name of our PCA predictor. And you should always make sure to delete your resources when you're no longer using them. Otherwise, you may incur extra processing or storage fees. Okay, so I kind of want to recap all the steps that we've taken. We went from defining a PCA model to training it on some formatted data. Then we took a look at the trained model attributes by loading in the model zip file with the MXNet library. We looked at the top n components and how much variance they covered in our data, and decided to use the top 7 principal components in our final analysis. We also care about the weights of the features that make up each component. This allows us to better describe the components that make up our transformed training data. Then to finally create our transformed data, we had to deploy our trained PCA model and apply it to our NumPy training data, and just now created a new transformed data frame. So this was a lot of demonstration around training and deploying a SageMaker model, and I left some of the data cleaning and transformation steps to you. Next, I want you to get practice with deploying models on your own, and so I'll give you some exercises around training and deploying a k-means clustering model. This final model will be created in a similar way to the PCA model. You'll define a k-means estimator, passing in appropriate parameters, and train it on this new transform data. So read through the following exercises and instructions carefully, and see if you can complete all of them, getting all the way to k-means model deployment and even extracting the trained model attributes. If you run into an error, try to debug as usual by looking through the logs and traces. I'll provide instruction, and I'm even linking to some relevant documentation, which can help you in passing in the correct arguments to a k-means model, for example. The end goal will be to assign clusters to each of our data points and see 1, which counties are assigned to each cluster, and 2, what that means as far as component and feature level makeup. This will allow us to describe the demographic similarities and differences between counties generally.